So what I'd like to show you here today is a way to measure a much larger resistance than a typical common meter can handle. This meter maxes out at about 20 megs or so for resistance reading 20 megohms. And our resistor over here, it says on the side of it is 480 megohms. So well past what this would normally be able to do. And the way we do that is we measure a known resistance, in this case a 10 megohm resistor, which is surprisingly close actually to 10 megs for a 5% resistor. And we then parallel this one here up across that and see what the difference is. So in our particular situation, we're going to call R1 is the resistance that we know right here. And we're going to write that down. We're going to call it 10.02. And that's in megohms. And we're then going to put this guy across it. Take that reading there, the total. So our parallel resistance here is going to, we'll wait for it to settle for a sec. And we got, let's call it 9.81. And here's our situation here. We're going to take our unknown resistor and we're going to parallel it up across our known resistor, 10 megs, and we're going to have a look at the difference. And we're going to measure the total resistance of the pair, and that's going to go in here. That value goes in here. The 10 meg value goes in here, and we're going to do our calculation. When I do the calculations on something like this, I just, because they're all megohms, I just ignore the millions, the megs, and we're just going to use the simple numbers 9.81 and 10.02. So 468 is our number, and turn it back into megohms, and there's your answer. So it looks like this high voltage probe is in good shape.